Hi everyone, today we're going to learn about two more ways to prove triangle congruence. We're going to learn about angle, angle, side, and hypotenuse leg, so AAS and HL triangle congruence. So angle, angle, side essentially says if you have two triangles whose corresponding two angles, so we have two angles, and a non-included side are congruent, then we can say that the two triangles are congruent. So notice here I have an angle, and then a side that is not included, meaning it can't be the one in between. And then here, angle, angle, and a non-included side. So if you see AAS, right, we want to make sure we have the information in that order, an angle, and then a side. So here we could state that these two triangles are congruent. Then hypotenuse leg triangle congruence theorem says that if you have a right triangle, so that's the important first step, it has to be a right triangle, and if the hypotenuse in one leg of a right triangle is congruent to the hypotenuse in another leg of a right triangle, then the two are congruent. So first, remember, we know that something is a right triangle if one of the angles has a little 90-degree symbol. Let's make sure we understand what the hypotenuse is. So the hypotenuse is always the side that's across from the 90-degree. So here you can see that this hypotenuse is congruent to this hypotenuse, so we see that with the double dash. And then a leg is just one of the sides that's touching the 90 degrees. So here and here, and you could see that these are congruent. So this is enough to show that these two triangles are congruent with HL triangle congruence theorem. All right, let's look at example 1 together. So it says, determine whether there is enough information to prove that triangle WVZ is congruent to triangle XYZ. So since these are both right triangles, maybe the first thing we can check for is that HL triangle congruence. So I see that there is a pair of legs that are congruent, but unfortunately we don't know that the two hypotenuses are congruent. So I'm seeing if there's something else we know. And if you notice right here, we have two lines intersecting. So we could actually state that this angle is congruent to this angle. So now I have one pair of congruent angles, I have another pair of congruent angles, and then I have a side. So this one we could actually use angle, angle, side. So let's state what we know that would help us prove this. So again, we see that angle VZW is congruent to angle YZX, so one in the corner. And again, this is because they are vertical angles. I see that angle V is congruent to angle W, and that was just given. And then we see that line segment VW is congruent to segment YX, and again, that was also just given. So if you look at what we have angle, angle, side. So this is enough to prove that they are congruent. So we'd say, yes, they are congruent. Okay, let's look down at example 2. So first for part A, they ask, are the two triangles congruent? If so, state the justification. And we'll provide some extra information to be sure. So let's look at what we're given. We're told that we have 60 and 60. Although it doesn't list 80 here, I see a doubled arc, so that means that this is also 80. And then I see 5 and 5. So we can list it out like this. We can say angle E is congruent to angle Q, angle D is congruent to angle P, and DF, segment DF is congruent to segment PR. So again, here we have an angle, and a side. So we would say that triangle, let's make sure we have an accurate statement. Let's say DEF is congruent to triangle. Make sure you match up the corresponding parts. It must be PQR because of angle, angle, side. And there you go. So if we look at this last example, we're given two right triangles, and then we see that one pair of their legs are congruent. However, we don't know anything else from the picture. So if we kind of list out the different ways we have to prove that triangles are congruent, here's what we've learned. We've learned side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg. So if you think that one doesn't work, we can go through the entire list. We don't have side, angle, side because I only know one side. So it's definitely not side, side, side. It's not angle, side, angle because I don't know anything about a second angle. Well, it's not angle, angle, side. Again, I don't know anything about a second angle. And then it's not hypotenuse, leg because I don't know anything about the hypotenuse of either triangle. So since we've exhausted our entire list, we would have to conclude that they are not congruent. But it is important that you go through the list and see if maybe one of the ones that we've learned previously might work. Okay, let's look here at example 3. So here it says, what value of x will make the given triangles congruent? And not only are we going to do that, but we're also going to explain kind of how we know. So if you look at what we're given, we actually have two right triangles. I have this right triangle, and I have this right triangle. And then one thing that you might notice is that they actually share a leg. So we know that JK is congruent to itself, and this would be the leg of a right triangle. So if these two triangles are to be congruent, then we know that the hypotenuse must be congruent. So we would like this angle, or this side, to be congruent to this side. We know that for them to be congruent, JL must be congruent to JM. And again, that would be the hypotenuse. So we could set up our little equation. JL is 2x plus 4. JM is 4x minus 10. So let's subtract 2x from each side and add 10. And we get x equals 7. So if x equals 7, then the hypotenuse of each triangle is congruent, and the two triangles would be congruent by HL, hypotenuse, leg. All right, let's look down here at example 4. It says a vertical tower supported by two wires as shown below. So here's our tower and here's the two wires. The wires are both 57 feet long. Let's label that in our picture. Okay. Is it possible to determine the distance from the bottom of the guy wire, AB, so the bottom of the wire to the bottom of the tower? So they're essentially asking us to solve for x, or is it even possible to solve for x? So again, let's look at the bigger picture here. We are assuming that since it's a tower, and hopefully it was built correctly, that it makes a 90-degree angle with the ground. So let's see what we know. Well, we know that the hypotenuse of each right triangle is congruent, and since this leg is part of both, we know that we can say it's congruent to itself. So I'm going to do this. I'm going to say AB is congruent to AC. Again, that's the hypotenuse. And we can say that AD is congruent to itself. That would be the leg. So due to HL triangle congruence, we know that triangle ABD is congruent to triangle ACD. And then thanks to Cpctc, which is corresponding parts of congruent triangles are congruent, so let me list that out. So because of Cpctc, again, corresponding parts of congruent triangles are congruent, we know that these two lengths must be congruent. We know that BD must be congruent to DC. They are the corresponding sides of the two triangles. So that means that this length is also 34 feet. So there you go. It asks to determine the distance from the bottom of the guy wire to the tower, and we found it using hypotenuse, leg, triangle congruence, and then Cpctc. Okay, this last example says, a carpenter builds a truss. So this is what a truss looks like, as shown to support the roof of a doghouse. Can the carpenter guarantee that JK, which is this length, is congruent to JM if JL is a perpendicular bisector of KM? So let's talk about this statement first. So they're telling us that JL is a perpendicular, so I'm going to put in my little 90-degree angles, and then bisector means that this segment is congruent to this segment. So what we know so far is the 90 degrees, and we also know that KL is congruent to LM because bisectors cut segments perfectly in half. So our job is going to be to determine if we can show in some way that these two triangles are congruent. So let's see again what we know. Well, we know that KL is congruent to LM, and again, that was because they told us it's a bisector. We know that angle JLK is congruent to angle JLM. And we know that because it said that this line is perpendicular, so both of these are 90. And you can see that this leg is part of both triangles, so we can say, oh, JL is congruent to itself. And now let's look what that gives us. Well, this gives us side, and then an angle, and then a side. So thanks to side, angle, side congruence, we can make the statement that triangle JLK is congruent to triangle JLM. And now we can look back at the statement that they're trying to guarantee. Do we know that JK is congruent to JM? Well, we can say that JK is congruent to JM thanks to Cpctc, which is corresponding parts of congruent triangles are congruent. So JK corresponds with JM, and since we know that the triangles are congruent, we know that that corresponding pair of sides is also congruent. All right, that is all for today's video. Thank you so much for watching.